What's up guys, this is Ronnie. Welcome back to tutorial 77, and today I'll be going to talk about how to load or how to create Neo4j graph directly reading from a CSV file. So in this tutorial we'll be going to use a sample CSV file, and this file will be having some sort of data, and each and every data will be going to denote as some nodes and properties and the relationship. So based on that CSV file we'll be going to create a graph directly inside your Neo4j database. So this is kind of reading from CSV file and creating a Neo4j graph. So this is going to be very exciting, and this is one of the very realistic use case you guys will going to tackle very frequently whenever you're going to deal with some sort of analytics driven application or any sort of like application. So ultimately your job is to read the data and going to do some sort of like graphing or creating a graph or anything. For example, you are going to deal with some sort of anomaly detection. Probably you are going to have multiple or millions of servers, and all these servers IP address and the traces and the different file system, whatever is actually access in past 5 months, 6 months or 10 months, the data will be presented to you, and after that maybe your client or company or the manager will going to ask you to do some sort of anomaly detection. So that time you have to read the data, and after that you have to create a graph based on those data. And after creating this graph you can create some sort of pattern for dealing with the risk detection or anomaly detection. So first of all you have to read the data, create the graph. So that part we'll be going to talk about in this tutorial. Okay, so for that actually I have one sample CSV file. So this is actually, I don't know, probably this is New York or some other US cities like station data, means the metro station data, means probably there are multiple stations names are there, and each and every stations are connected to few stations. Many train names are there, and each and every trains are like for each train there are connected station. For example, train A goes to 5 cities and train B goes to 7 different cities. Now our job is to create a kind of a station or like station route or train route kind of a diagram where no duplicate will be presented for a same train, and each and every station will be connected to the train node based on the CSV file. So what is the expected output? No duplicate node for the same train. For example, in your list you are having like 5 different or 5 unique trains, and every 5 trains goes to 100 different station. So our job is to create only one node for train, and from there we have to connect the different stations. It is not going to be like one-to-one relationship for train and station. If it is going to be one-to-many, means one train multiple station, and that will be connected. So the connection will be definitely going to have some sort of relationship. So we'll be going to talk about this thing, and also we'll directly read the data and create in our Neo4j. So code and everything I'll be going to show you. So first of all let me show you guys in this tutorial I'll be going to use my local Neo4j browser. So first of all we'll see if I have any data or not. So match n, return n. Okay, fine. So I have no data as you can see over here. So we'll be going to read the data from CSV file now. Okay, so first thing first, let me give a name for this tutorial. It is going to be tutorial 77. Then create Neo4j graph using CSV or from reading from CSV file. Okay, so this like this. Okay, so first thing we're going to import all our required libraries. So we are going to deal with CSV files, so definitely pandas, import pandas as PD. Then we are going to import the Neo4j library. So it is from Neo4j import graph database. Then we'll be going to create the or establish the connection first. So it will be driver equals to graph database dot driver. Then URI is going to be like this, then auth. Okay, so it will be Neo4j, then and password is this. Okay, now let me just get this bold protocol address from here, copy from my local Neo4j desktop, and I'll be going to put this thing here, and after that I'll create a session. So session equals to driver dot session. That's it. So we'll execute this thing now. Okay, so no error means everything is working fine. Okay, so now we'll read from the CSV file. So df equals to pd dot read CSV, and our CSV file is here actually, station.csv. if you see, this is a CSV file, so I'm not going to load it from here, rather than I'll be going to read it from here. So station.csv, okay, so import, then just df, so you guys will be able to understand what is there. So URL object ID, so this is my station's name, and I don't need this geo coordinate, and this is my train name. Okay, so train name is going to be unique always, as I said, like see, for example, this train goes to this station, and this train again same train goes to this station. So so what is required here, there will be only single node for this thing, and we'll be going to create two relationship. One will be connected with this one, and one will be connected to this one. So for every train there will be only one node, and each and every station will be connected to that train only. So that is required. So none of the other things are required for us, only this and this thing is going to be used, like name and line. Okay, so that's it. So I believe you guys understand. So now we'll be going to start the actual coding. Okay, so first thing, we need to identify how many unique things are, unique trains are there. So let me just create a variable stations, okay, like this. So it should be df dot, sorry, not station, this is trains actually. Okay, trains equals to line, not line, and we're going to write unique. Okay, so this will give you the unique things, so unique trains. So if I run this thing, this gives this many unique. Okay, so I don't need this thing. So now what we'll do, we're just going to write the query. Okay, so q1. So before I run the query, there is one thing is required. For example, if you see this thing, like, okay, let me again open this, the data frame, then. So I don't want this thing to be duplicated, this thing. Okay, so I want to create a, what do you say, like I want to create some sort of, what do you say, like some sort of constraint that this should not be duplicated, and this is also should not be duplicated. Like one station, once this is created, this should be connected to this one. Again there is another like train which is also connected to that station, so same station name should be connected. Means, for example, *pi should be present in this like the station *pi should be present in this file for the 5 times, and every time it is connected to a different train. So I should not create many to many relationship for every station as well. So one node for one station, and also if there is multiple train, so it should be connected in that way. So if like complete metro route map, or like a station map, or like some big cities or big countries are having this sort of things like metro chart or whatever, like what do you say, like I don't have the like actual word. For example, in London they have this thing called tube map, or in Singapore they have this MRT, or in Germany they have this what do you say, like a Bayern train route, or MBB. In different cities are having different things. So that is how it is. Okay, so we'll be going to create the same sort of structure, and we'll see how to do it now. Okay, so next thing is that we need to create some constraint so that name and line should not be duplicated. So how to do that? So for that actually we have to write a very simple query. So this is going to be constraint, so it would be create constraint, okay, on, and after that maybe I can just give a name, and my label will be, let's say, train. Actually maybe I can write train. Okay, train. I'll be going to create a node for train, and for the station it will be station. Okay, and it will be like assert. okay, then it should be a dot train name is unique. Okay, what is the problem? Okay, I did a mistake, so it should be UNI unique. So one constraint is created, so we'll be going to do another constraint, so it should be station, and here it should be station name. Okay, just remember we are creating two different constraints. Okay, so that's it, done. So now we'll be going to write down the query now. Okay, so query will be written from here. So it should be there would be merge condition, to merge condition first, and this is going to check whether we have these nodes are created or not. So if you have some constraint applied on some property, then what will happen? If it finds the node, it will not do anything. If it is not able to find anything, then it will create the node. So that is why I'm just going to do this thing. So it should be a, then train. Okay, then can write something I said like train name, right? So it should be small train underscore name, and I'll be going to give this thing one variable for the time being, train name. We'll see how to derive this variable, but for the time being just think about this. So we'll be going to first check whether this train name exists or not, sorry, and after we'll see this station name actually exists or not. Okay, so let me write this thing. So it should be B, maybe in caps will be better, B, then it should be station. Okay, and here it should be station name, and here also it should be station name. Okay, then we'll be going to merge the relationship now. Merge, so A should be A, then this, then goes to, means trains goes to this and another station B. So this is what we are looking for, right? So if this train name exists, it will not do anything. If this train name exists, it will not do anything. It will just go and merge this thing. Okay, and if it doesn't exist, it will go and create. Okay, so next thing we have to read one by one from this thing. So we got our unique things. Okay, so what we'll do now, for train names, maybe for T names in trains, this is actually list, so I'll be going to get the all unique trains name like this. Okay, so what will happen, we'll be going to do a group by query. Okay, like from here we'll be going to apply group by query for every unique train name, and we'll get all the corresponding names. Actually means from the train name we'll get all the corresponding station names. So that is why I'm just doing this thing. Okay, so it will be df dot group by, right? So inside that I'll be going to put the this thing. Actually let me write, this will be line. Okay, and this should be like this, so it should be name. Okay, it should be line. Okay, right, and we'll be going to do it should be get group. I'm not sure, I'm not getting that, get group, and inside that this thing, I'm just thinking, get group, I just need what do you say, like I need the train name, actually get group, and from there I need to get each and every this name. Okay, so get group means I have to use this thing. Okay, so it should be t name, and from there I need only the names. Okay, so that is why I have to use name actually. Okay, I need only name, nothing else. Okay, that's it. Okay, and once this is done, we'll be going to start writing one more for loop. Okay, so why one more for loop? Because this x is going to be written with so many different stations, right? Means for one single train there could be multiple things, and that is going to be present here. So this is also kind of a list. Okay, so not list, this is actually we can iterate this thing using this thing, but this is not list. So probably you can write s name in x, and now we have to create our variable, like dictionary variable. So we have this thing train name, so we should write train underscore name. This is actually, this train name means this t name. Okay, right, and we have one more station name, so station underscore name, and this station name means this s name. Okay, so s name, and now we'll be going to write down the query. So it should be session dot run and q1 and p. So what will happen now, this will run this query with this dictionary. Why this dictionary? Because in our query we have these two variables, train name and station name. And what does it mean? This train name is actually replaced by this t name variable, which is actually this one, and this station name from here will be replaced by s name. What is s name? S name means every element from this thing, means for every train, for every time we have a list of stations, so that is actually going to be present in variable x. For every element from x will be denoted by this s name, and for that we'll be going to write down the thing. So I believe I haven't done any mistake. If I run this thing, it will take 2-3 minutes, and after that it will create everything here. So what I'll do, we'll check if I have anything here or not. So I have nothing, so hopefully let's run this thing. So see, something is happening here, so it means it is doing something. So let's wait for some time. So it is done. So if I run this query again, so we'll get so many things over here popped up, like nice graphs. Okay, so see the magic. Okay, so let's limit this thing, probably then it will be easier. So let's limit 20. Okay, see, you understand this thing now. Okay, see, 1.2 is a train which goes to this station 86th Street, like 59th Street. So if you see here, and if you see here, we haven't like created any duplicate, so our constraint is working fine. So if you see here, this train connects to this many station, and this train also connected to this many station, and out of that these 3 stations are actually connected to this train and this train. So this is how the metro route maps developed, and some other like use cases and scenario also can be built on the applying the same logic. So this is very useful, this is very simple. You have to understand the very few basics of CYPHER query, for example merge and constraint thing, and after that if you are good in Python you can do so many things. Okay, so that is the objective for today's class. So in the next tutorial we'll see some more real world applications or use cases. So probably something else, but I'm not sure today what will be happen. But as you can see guys, I'm actually coming up with all fruitful and useful information and use cases, whatever actually going to be used in your project, in your future work, or maybe some of you already requested for the same thing. Okay, so let me just complete this thing first. okay, so or else I will definitely forget. So download, let me put the screenshot like this, but this is not the actual thing. Just for sake of putting into the screen, I just do it, but actual numbers are huge. Okay, so if you want to see the actual number, probably just remove this thing. So like this will come. So and you can put some sort of put some sort of count here. Actually I forgot, count 10. Okay, so this is 421, and how this 421 came, so you can you can use this thing. So this is going to be give the unique trains name. So let me just put length of trains. So this gives you this thing 66. So now I'll be going to get the unique stations, actually how many unique stations are there. So probably this will be name and maybe essence like this. Okay, then let's like F and F. What happened? Okay, sorry, so it should be capital actually. So if you calculate this thing 355 plus 66, it is actually going to give you 421. So everything is perfectly okay. So just give me a minute, let me just copy this code. I believe this is the only code you required to put here, because remaining things will be definitely I'll be going to share this thing from my GitHub repository as well. Okay, so that's it guys. I hope you guys are enjoying this series. So this is 77th tutorial, so a lot of learning for all of you, and lots of new stuffs are coming in the future videos as well. But one thing you guys might notice that I actually stopped doing a normal query, and I'm actually just focusing more or less on the actual application side of Neo4j and Python. So in future videos are going to be more advanced, more like complex. So I'll highly recommend you guys to do some sort of practice, some sort of coding, try to analyze, explore Stack Overflow, Neo4j documentation, whatever you want to do, or else it will be difficult for you in the coming days. And in between, if there is any question or if you guys need any clarification, please feel free to ask me. I'll always there to help you. Okay, so enough of talking guys, I think we should close the video now. So we'll see you in the next video. Till then, take care, goodbye, and have a nice day.